The broadcast is now starting. All attendees are in listen-only mode.
Good morning, ladies and gentlemen. This is Tom Norman, and I want to welcome you again to the Virtualization Virtual Group at PASS. We've taken a brief hiatus for the last few months, but we're back with Brian Carrig today on planning for virtualization. So if you've never done virtualization, this is definitely the place for you. And I know Brian very well. He's here locally with me in the Raleigh area, and we're both active in our local user group. So welcome, Brian, and I'll let you take it away.
All right, thanks, Tom. So as Tom mentioned, I'm Brian Carrig, and this particular presentation is about planning for virtualization, and it's basically a guide to virtualizing SQL Server. If you have already virtualized SQL Server and you're encountering issues, please feel free at any stage. Tom, do you want all the questions kept to the end, or is it fine for people to raise their virtual hand and ask a question during the presentation?
Just as long as you're good with it, we can do it during the presentation if you like.
Yeah. All right, that sounds good. So if you have a question as we go, please feel free to raise your hand, and I guess they can put it in the chat window. Is that how it works, Tom?
Yep, puts in a chat question window, and then I'll grab it and read it back to you, or either paste it to chat to you.
Okay, sounds good. All right, so let's get started. There we go. Okay, so who am I? So currently I work as a site reliability engineering manager at Citrix ShareFile, which is a file sharing service belonging to Citrix, here in the Raleigh area, as Tom mentioned. And previously, because SRE roles are kind of new-ish and encompass kind of broader range than just traditional siloed ops, I will mention that I was a database administration manager at a company called Channel Advisor prior to joining Citrix. And currently, our hardware is all in AWS. So the reason I mentioned my previous role is because they're all on-prem and fully virtualized using VMware. So even though my company sells a virtualization product, I will mostly be focused on VMware. Microsoft Certified Master of SQL Server, and I'm about 7 years working with SQL Server now. And my contact details are on there. Please feel free, if you want to follow up with questions after the session, please feel free to reach out to me either on Twitter or email. And Twitter's liable to get you a faster response, but obviously the messages tend to be shorter. Okay, so the agenda for this session, we're going to go through some of the pros and cons of virtualization, because it is not for everyone, although I imagine that for pretty much every enterprise now uses virtualization to some degree, even if there are some applications that whether legacy or just sheer size cannot use virtualization. So I'll talk about some good virtualization candidates. If you're looking at a particular workload and thinking, hey, maybe I should look at virtualizing this. Some of the infrastructure design, how you design your virtual machines. I'm going to cover instance level configurations, which don't differ greatly from what you would do in the physical world, but I think it's important to cover it as well. Just because there is a lot of bad advice out there where they say, hey, if you virtualize, don't worry about it, put it all on one disk, etc., etc. And then I'll give a checklist that DBAs can kind of take away with them if you are looking at a new virtualization project, and something that you can take with you and talk at the same level as your systems administrators or whoever else you might be dealing with, or virtualization administrators. And then we'll summarize. Okay, so pros for virtualization. Well, for a start, you get server level high availability for free as part of the virtualization package. And I'll talk a little bit more about this later in the session, but do remember it is only server level. VMware or Hyper-V or whatever, Zen server, whatever you choose to use, it has no awareness of SQL Server. So you could have an issue with your database, but as long as the server is up and running, as far as VMware is concerned, everything is talk about some of the maintenance and storage migration benefits, disaster recovery options with virtualization, the ease of consolidation, cloning and templates. These are some of the benefits that you get. In particular, I think I want to point out the storage migration benefits, because typically SAM upgrades involved a lot of work for the DBA. We had to set up log shipping or some kind of synchronization mechanism in order to migrate from one storage to another. If you in the virtual world, assuming that you're using virtual disks, you can simply migrate from one storage to another at a click of a button, which means a lot less work for you as a DBA. As I mentioned, cloning and templates can be used to kind of keep things in sync and prevent configuration drift. You get the option of snapshots, a certain degree of load balancing, and you get to add resources as and when you need them. So this is not all CapEx up front. You can basically create your VM at the size you want, or the size you need right now, unlike in the physical world where you might, the hardware is expected to last 3 years, so you basically have to buy now what you need in 3 years' time. So cons of virtualization. Well, for one, as a DBA, we like to keep control of everything that we manage, right down to the hardware level. So virtualization may potentially come with a certain loss of control, particularly if you don't have any visibility into the virtualization layer. I'll talk a bit more about that in a second. There's not really any performance benefits. As a DBA, we're all about performance. We want faster storage or more memory or more CPU, and these are going to deliver more performance. Virtualization is more of a manageability tool, so it doesn't deliver any performance benefits, except in very rare cases. And usually that will be related to better driver configuration or newer driver configuration. It's yet another layer that you need to troubleshoot as a DBA when there's a performance issue, which things are already complex enough. Now we have to worry about things like virtual Numa, as well as physical Numa. Things like that. We need to worry, our hosts over provisioned. It's just yet another layer where problems could be introduced. Potentially less visibility into the infrastructure, and it also limits our storage options. If anybody is using NVMe, they will know that it's really, really fast, but typically you need to set it up as local storage, or certainly to maximize the benefits. And with virtualization, in order to utilize it fully, you need to have shared storage. So that can cause a limitation on your storage options and can also drive your costs up. So good candidates for virtualization, in my opinion at least, are that you have an experienced virtualization team. That's really important. If your system administrators are really only getting their foot in the door or getting their feet wet with virtualization as a concept, which is probably quite unusual these days. Most places are quite familiar with virtualizing to some degree. But if they are, database is not the place to start. So convince them to go virtualize the web tier first and then come back to you. If your DR plan relies on virtualization, well then virtualization is obviously a good idea because you'll have a DR plan. If you've got some really old versions of SQL to support, although you no longer have support from Microsoft for SQL 2000 or SQL 2005, not even extended support, you can at least get around any hardware warranty issues by virtualizing the server, doing a physical to virtual conversion, and then at least the hardware warranty issues are out of the way without you having to do a whole lot of work. And the other thing to make sure, and this is increasingly rare, is that you are unlikely to hit the maximum on your VMs, which in VMware 6.5 is going to be around 6 terabytes of memory and 128 virtual CPUs. So it's rare that people need to get above that. It does happen, of course, but it's rare. So, poor candidates for virtualization. So if your systems administration team have no prior experience with virtualization, as I mentioned, you really don't want to start with the database tier. And this could kind of rule out virtualization as an option for your databases, at least initially. If all of your high availability or disaster recovery plans are based around the physical world, and you're going to lose these benefits by moving to virtualization, that is something that you need to consider. Doesn't necessarily rule out virtualization, but certainly it is a negative, in my opinion. If you're based on your application design, scaling up continually is your only option, then again, if you're likely to have to scale up beyond the limits of what VMs can support, well, then that could be an issue. That feeds into the configuration maxims are concerned. And it's not just around the number of CPUs and the size of the memory. You have to think about the number of SCSI controllers that can be supported, the number of virtual disks, the size of the virtual disks, and so forth. If you use third-party vendor software, and they do not support running on a VM, well, then that could be a blocker. Because if they find out you're running on a VM, they may no longer support their own application, which could cause problems for you. And if you have a lot of heavily customized instances, lots of unique special snowflakes out there, okay, it's going to be tough to manage, and virtualization may not be of much assistance in managing that. Okay, so as I mentioned, currently I work for Citrix, but we run everything in AWS, so that's not much use for the point of this presentation, although I do give talks on AWS as well. At Channel Advisor, at least before I left, we were 100% virtualized, running VMware vSphere 6.5, which equated to about 147 production SQL instances. I believe they're currently on SQL 2017 CU6. We must have been around CU4, I think, when I left. And it's a combination of clusters, all Dell-based, or 820s, 730s, and 740s. And running as separate clusters because you really want to try and keep consistency across your hosts. It certainly makes life less complicated if all your hosts are the same CPU generation and the same sizing. Sorry, went too far there. Okay, so this is kind of general advice that I would give to DBAs for any project, and they also apply to virtualization. So if something is coming anyway, perhaps think about, apart from just virtualization, things like containers, public cloud. If these are going to come and you're going to have to support them in the database tier as a DBA, it's always better to engage upfront and then retain some influence over design and how the project is implemented, rather than just simply dig your heels in and resist and say, no way are we containerizing, virtualizing, or moving to the public cloud on any of my workload. Don't rule it out and just engage, voice your concerns, and try and influence the project as much as possible. Visibility is key. I'll talk a bit about in the virtual world, you should be able to get read-only access just to have visibility into the virtualization tier, so you can quickly rule in or out whether there's an issue there when problems arise, and also you can set up some monitoring around your virtualization tier. Feeding into that is the idea of avoiding silos, that you only look at the database and you're relying on someone else to make sure and tell you that the storage is okay, that the virtualization tier is okay, and so forth. And this really requires trust and communication between teams, which is also one of the central tenets of the DevOps movement, which, although it means many things to many people, was originally started as a way to have better communication between development and operations through automation and quality up front. So, as Reagan said, trust but verify, and that's really the key. You want to be able to have visibility into the virtualization tier so that you can verify what you're being told. Not that you mistrust your sysadmins, but just so you can verify it. Tom, has any questions come in so far, or are we good?
We're good.
Okay, cool. I say, don't be afraid to ask questions as they arise. So you have a lot of options for hypervisors out there. Most on-premise private cloud type options. Typically, VMware is the biggest player in the market. It's not as big in the public cloud. Obviously, Microsoft's Azure uses Hyper-V. AWS, which is the largest public cloud, use Zen Server. But there are lots of options out there. And the reason VMware vSphere isn't typically favored by public cloud companies is just surely due to the cost. But yeah, so there's lots of options, but VMware tends to be the most common, probably about 50% of the market last time I read. So when it comes to designing the infrastructure for your virtualization cluster, if you're lucky, and hopefully you are, you will be able to keep your SQL servers in a completely separate cluster. But if you only have a small amount of SQL instances to support, this may not be practical or necessary. But no matter whether you're mixed in with other workloads or not, it's really important that you try and keep consistency across your hardware. That's very desirable, as it's easier to move things around and it's easier to calculate what your failure tolerance is within the cluster. If you feel that you need to overcommit, and by overcommit I mean that we allocate more resources to the VMs on a host than physically exists on the host. And this would be physical cores rather than logical cores, because a physical, again, I'll talk about this in a bit, but a physical core and a logical core are obviously not equivalent. And when it comes to memory, yes, it's the amount of memory available on the box. So if you're going to look at overcommitting, and a certain amount of overcommitting might be fine, make sure that it's agreed up front what that will be and what that will look like. If you're going to do all of the work to move into new hardware, this might be a good opportunity to upgrade your version of SQL Server, as you will have engaged your QA teams, your development teams, your sysadmins, and you're performing a migration anyway. This might be a good opportunity to look at upgrading to the latest version of SQL Server. A very popular option for licensing when it comes to both Windows and SQL is to do host-based licensing, which is where you license all of the processors on the physical host, and then you are allowed to run as many VMs as you want on the host, essentially. This requires software assurance, and I will talk a little bit more about that later in the slide deck. There is something called Enhanced vMotion Compatibility Mode, which allows you to mix and match different processor generations, but be aware that enabling this, well, it will allow you to mix, as I say, mix and match different generations of CPU, will lock out a lot of the performance optimizations in newer CPU architecture. So I would avoid that if at all possible. And you may have a situation when you move to virtualization that whereas previously you had an abundance of CPU, you perhaps have less. And this is something that's coming anyway as we have core-based licensing now. So try and allow a certain amount of time to performance tune if you're gonna have a situation where you're gonna have to deal with fewer CPUs than you had previously. Okay. So when it comes to configuring your ESXi host or your whatever virtualization platform you were on, one key thing to be aware of is your BIOS settings. So I include an example here, and this really did happen. We purchased the performance BIOS, and it came from Dell with power saving enabled. So it took us a while to figure out why our VMs were suddenly freezing, dropping packets, causing connection failures, and it was basically down to power saving being enabled. So in your BIOS on your host, make sure that you set your power settings to or power saving settings to either be disabled or to allow the OS to control them. Okay. Further on infrastructure design, this is a trade-off that you'll have in the physical world as well, of course, but you really get the trade-off between faster cores or more cores. And certainly for OLTP style workloads, it may make sense to, because single-threaded performance is so important, it may make sense to save money on licensing by having fewer cores that are run at a higher clock rate. But this may not apply to more batch-oriented or OLAP-style workloads, such as traditional data warehouses. Be aware that logical cores are not the equivalent of physical cores. Typically, you can expect maybe a 10 to 20% performance from hyperthreading, performance increase from hyperthreading, but you will not double your performance by switching on hyperthreading and having more logical cores than physical cores. In any case, the most frequent bottleneck, because you have to use shared storage, is the storage subsystem itself, either the path to the storage or the storage itself. Make sure that you spec your storage based not on the capacity that you require, but also on the IOPS that you need, and the actual performance that you require. Particularly limiting is, and it's less and less frequent now, I imagine, but 1 gigabit per second iSCSI paths to storage are extremely limiting. I think they work out at about 100 megabytes per second, if I'm roughly translating, so or about the speed of a single SATA disk, magnetic disk. So anything more than a one-to-one mapping between physical cores and virtual CPU is considered over allocation. As I mentioned, a certain amount may be okay. You also need to, I would avoid overcommitting memory on SQL Server because of the way SQL Server allocates memory. VMware frequently thinks it is not being used, even though it is. So I would try to avoid overcommitting on memory. And you need to budget for failover capacity. And by that, I mean what VMware calls admission control. And basically, you set how you want to handle your failover capacity, whether you want it to be a percentage of the cluster resources, or, and this is the default option, reservations. So basically, it calculates how much it needs to divide your cluster up into slots and makes a kind of worst case scenario where the host with the largest VM fails and you need to have a slot essentially available on other hosts for those VMs to boot up. And when admission control is enabled, and it's enabled by default, but you can switch it off. I don't recommend that. When admission control is enabled and you exceed your failover capacity that you have set, then you will not be able to boot up VMs, essentially, new VMs. Or if you have a failure, if you do go over your failover capacity and you have hardware failure, not all your VMs may be able to be rebooted on a new host. And the last option, and kind of simplest option, but only makes sense for very small clusters, is to allocate a dedicated failover host. So one host in the cluster will not have any VMs running on it, and in the event of failure of a host, new VMs can be booted up on the failover host. And make sure that right up front that you explain to your sysadmins that the consolidation ratios that they might expect from file and print servers or web servers may be unlikely to apply to something as performance sensitive as a SQL Server workload. Okay, a very brief slide on licensing. This licensing for the virtualization, it can be quite complex. Licensing is complex anyway. I'm only giving my informed opinion and not a lawyer, etc., etc. So for 2014 and above, you need software assurance in order to have what they call mobility rights. So this is basically the ability for VMs to move around the cluster, either on the event of failover or just for load balancing purposes. As I mentioned, host-based licensing can be a cost-effective option and certainly is easier to calculate than other options. If you were running standard edition, you're not running enterprise edition SQL Server, you have no host-based licensing options. And the minimum that your VM can be licensed for is 4 cores. So even if it is only using 2 cores, you still need to purchase 4. One of the cool things about host-based licensing as well is that because you can run any VM as Enterprise Edition on the host as long as the host is licensed, this allows for smaller VMs that typically might not justify having Enterprise Edition to run as Enterprise. So to give you an example of some of the maximum configuration options, for vSphere 6.5 and Hyper-V on Windows Server 2016, number of virtual CPUs for vSphere is 128, and virtual CPUs for Hyper-V is 240. Obviously, your host has to have that level of capacity available in logical cores in order to allocate. And then RAM on VMware is 6 terabytes and up to 12 terabytes on Windows Server 2016. And then when it comes to disks, you can have on the SCSI side, you can have 60 by 62 terabyte, up to 62 terabyte disks, and the same again for NVMe on vSphere, and then it's just 256 total by 64 terabytes in the Hyper-V world. Okay, so one of the really important principles of VM design is that you right-size your virtual machine, by which I mean that you set the appropriate number of cores. Don't just go as wide as you can and say that's what you want, because that can actually have a negative performance impact on your because all of those cores need to be scheduled at the same time, even if only 1 or 2 of them are being used. And there's a certain amount of what's called relaxed co-scheduling, which means that VMware can kind of compensate, but for the most part, you can basically think of it as that if you set your VM to have 24 virtual CPUs, that every time it needs to do some work, it has to find 24 free cores on the host and use those, even if it's only at the time using 1 or 2 cores to do the actual work. And I'll talk about Virtual Numa a bit more in a second, but be aware that by default, it gets automatically applied if you assign greater than 8 vCPUs to your virtual machine. And what Virtual Numa will do is basically represent to the guest the Numa configuration of the host. You also get hot add options, which are incompatible with Virtual Numa. So something that you need to think about up front is which do you prefer to have. Hot add is really useful in VMware, particularly hot add memory. I imagine it's less utilized in the physical world where you don't really want your sysadmin standing over an open server with a running workload trying to insert RAM into it, although I guess maybe it happens. But hot add memory is compatible with Virtual Numa, but hot add CPU is not. And so, yeah, just something to be aware of. If you're using availability groups, or failover clustering, you can use what's called anti-affinity rules. So basically, you say you take the two VMs and you tell them not to run on the same host, essentially, which makes a lot of sense because there's no point in having a synchronous availability group and having a single host be able to take down both nodes. So you have them run on different hosts. These affinity rules can also be useful for licensing, particularly in situations where you don't get your own cluster specifically for SQL Server, and you don't want to actually spend licensing dollars on hosts that aren't going to run SQL Server workload. In those scenarios, you can set affinity rules to allow VMs that are running SQL Server to only run on certain hosts and still stay within licensing compliance to just license those hosts, even though the entire cluster is joined as one cluster. Yep. Okay. Yeah, and if you are using virtual Numa, it makes sense to align with the physical hardware. And this is one area where I think that Hyper-V has a better representation than VMware, because VMware for Numa purposes only considers CPU, whereas Hyper-V you can represent both the memory and CPU when it comes to Numa. But it makes sense to align if you're using virtual Numa, to present to the guest something that matches with the physical hardware, with the possible exception being scenarios where you have a very memory dense VM and that's possibly going to spill over across multiple Numa nodes. It might make sense to separate out based just on the memory. Okay. Again, assuming no questions, we'll keep going.
Yep, no questions.
So one of the things. Okay, thanks, Tom. So one of the things I strongly recommend, and it's in VMware's own best practices as well, is to reserve the memory when you're enforcing admission to enforce admission control. So by reserving memory, it means that all of the memory is carved out for your VM at startup. So if you want to give it 64 gigabytes of virtual RAM, all that 64 gigabytes is locked out of the host. And I think this makes a lot of sense because, as I mentioned, because of the way SQL Server uses memory, it's not clear to the guest Windows operating system. I haven't checked if this is different for SQL Server on Linux, but for SQL Server on Windows, it doesn't. Windows cannot keep a good track of what memory SQL Server is using, and it kind of looks like it's sitting idle. And this can, in a situation where you're overcommitted on memory, this can cause VMware to engage in behaviors such as swapping or what they call ballooning. And ballooning is where it takes back memory that it sees as idle from the guest VM by artificially, basically a service that's running on the VM will artificially consume memory so that it can pass it back to the hypervisor. And if this happens on a SQL Server workload, this could result in basically a lot of memory suddenly being taken away from SQL Server and paged out to disk, and you can imagine the performance issues that causes. Traditional solution, you don't see this quite so much anymore, but certainly in the early days of virtualizing SQL Server, a lot of people would recommend that you disable balloon drivers. I don't think that's the solution. Instead of disabling your balloon drivers, why not just go ahead and reserve the memory? And in that scenario, VMware will never try to take it back. Okay. Another important concept when it comes to virtualization is this concept called ready time. So that's basically the amount of time that you essentially spend waiting for a workload to be scheduled on the CPU. And it's that delay presented as a percentage of CPU time available. So for workloads that are particularly latency and performance sensitive, like SQL Server, the impact may be noticeable at anything above 5% is typical guidelines that VMware gives, but your mileage may vary. A lot of it will depend on the sensitivity of your own workload. So and also always be sure to account for the number of virtual CPUs. And again, this really applies, especially if you have a lot of VMs that are differently sized. It may be easier for a 2 virtual CPU VM to get time scheduled on available schedulers than it is for a larger, 64 vCPU VM. It may spend much more time waiting to get for all 64 cores to become available so that it can schedule work. But the way you track that in any case is ready time. Okay, so I've mentioned virtual Numa quite a few times, so I'll delve into it a little bit deeper here. As I mentioned, it's not compatible with hot add CPU. So if this is a feature that you feel you will need, you can't use virtual Numa. Take note of the memory that's available per Numa node as well, as this may influence how you want to present virtual Numa or the virtual Numa configuration you create to present to the guest. But typically, you will be aligning with the physical cores per socket. So if you have an eight physical cores per socket on your CPU, that's what you tell your guests that you have. And again, it's not always beneficial. We found in our testing at Channel Advisor, we found that our 2-socket CPUs or 2-socket servers had greater benefit for virtual Numa than our 4-socket servers. So definitely do some testing around this and find out if it is something that benefits your workload or not. So by default, if you create more than 8 cores on your VM, it will use virtual Numa. That's by default. It's configurable. If you're living in the Hyper-V world, virtual Numa is not compatible with dynamic memory. And also be aware of that if you're using SQL 2016 and above. Well, soft Numa is always available right back to SQL 2005, but in SQL 2016 and above, if you have 10 CPUs per socket, 10 cores per socket, physical cores per socket, or more, it will automatically enable soft Numa in an attempt to improve performance. So this can cause quite a lot of layers in your Numa configuration, because you have soft Numa enabled for SQL Server, then that feeds into virtual Numa enabled on the guest, right down to the actual physical Numa configuration. So that can lead to a lot of weird troubleshooting issues. So be sure to test before you decide what you need there. But for smaller VMs, this is obviously less of a consideration. This is really for your larger VMs that you're going to be running tier 1 workloads on. Okay, storage considerations. You lose a lot of benefits if you use what they call raw device mapping, whether it's physical or virtual raw device mapping. So this is essentially taking a LUN on your SAN, presenting it to your guest VM, and allowing it to write directly to it. This doesn't create the overhead that using a virtual disk does, but the overhead is so minimal as to be unnoticeable. So I would recommend using VMDKs in VMware World. You could just use in-guest iSCSI, but this means that your guest VM will be using CPU to perform I/O operations. And also lately, again, more so for the smaller shops, you can use VMware's own virtual SAN, and there are also various third-party vendors that sell virtual SAN products. And this can be a way to use physical storage that's local to the machines as a shared storage object. Hyper-V has kind of similar concepts with pass-through, dynamic, and fixed. Fixed is where it allocates all of the disk as you start, And that is what I would recommend if you're using Hyper-V. And things to be aware of in the vSphere world is that the data stores themselves can become a bottleneck. It could be access paths, it could be queue depths, it could be kind of hot spots on particular data stores. So just something that you need to track. If you don't use a virtual disk, you do not get the benefits of storage vMotion that I mentioned earlier, and that really is a neat feature. So I would try and use virtual disks. If the small single-digit percentage overhead that's potentially there between raw device mapping and virtual disks is a cause for concern, you may want to reconsider if your workload is worth for a good candidate for virtualization, because it's clearly very I/O sensitive, and you may not want to deal with even the smallest amount of additional latency. But as I said, when we did any testing around this, we saw almost no overhead difference between RDM and VMDKs. Okay, so one of the things that comes up frequently is if I'm virtualizing and underneath is all shared storage anyway, is there any point in doing the traditional separating of the various different disks or mount points? In this case I've outlined, you might have one for your OS, one for your user databases, one for your transaction logs, one for your system databases, your Windows page file, maybe another for backups, and then another for tempdb. I would still say that this is an exercise worth doing, because you will get, different, when it comes to backups, you might get different multiple threads running. There will be different queues for each. You'll be separated across multiple SCSI controllers. So there are still benefits to doing this, even if underneath they're all this workload is just hitting the same single shared pool of disk. As I recommended, use virtual disks. And if you're in Hyper-V land, use fixed disks. That's surprisingly hard to say. And if you're in the VMware world, the option to pick is tick provisioned eager zeroed. So basically, it will provision all of the disk, and then right from the start, before it actually presents the disk to the VM, it will zero it out for you. Okay. Moving on to instance level configuration options. Hopefully these will be all pretty much the same as what you would do anyway, with the exception of virtual Numa, but I think it's worth going through them anyway. And these are kind of changes, or how I would like to typically configure instances. So do set the max server memory for your instance, leaving enough headroom for your operating system and any background processes that might be running on there. My typical rule of thumb is the larger 4 GB or 10% of the available memory to be left to the OS. I like to enable lock pages in memory. That's debatable. I have also run configurations where I set min and max, but typically I will start with lock pages in memory. I enable instant file initialization, and the lower of the virtual Numa node core count, or 8 cores, is how I set max stop typically. The cost threshold for parallelism by default is 5, which I think is really low, particularly on modern hardware. So I normally start at 15 and work my way up to around what makes sense. It will all depend on the workload and how frequently you want things to go parallel. I see configurations as high as 100, and that can be fine. Large pages is something you want to consider, but it does only suit certain workloads and can cause, because of the way large pages work, so essentially all of these larger 2 MB pages in memory, not to be confused with a data page in SQL Server, need to be allocated contiguously on startup. So this can cause startup to dramatically slow down and take a long time to start up. So if that is the case, you may not want to use large pages. It is recommended by VMware by default, but I would say use it cautiously. And your temp-db data file count, as a general rule of thumb, the smaller of the number of processors, or 8 files. And if you start to see allocation contention, then increase in groups of 4 until you hit a sweet spot where you're not seeing it anymore. Then again, also by default, I switch on optimize for ad hoc workloads. That is in no way influenced by being virtualized or not. So benchmarks and baselines. These are really important. Erin Stellato has a good presentation out there that she's delivered to both real user groups and I believe some of the virtual user groups, so should be downloadable somewhere, where she talks about the importance of baselining. So what I would say is you really want to avoid scenarios where people in the room are having subjective conversations about performance, where people are saying things like, it feels slower, and nobody can point to any solid metrics. If those are the kind of conversations you have, then it points to a lack of a proper baseline. Monitor your wait stats. These are really important, particularly as you move from physical to virtual, to see if anything is changing there. For example, maybe suddenly you see a lot more I/O related waits. This would be important to know, as it may point to underperformance of your new storage subsystem. And while you're testing, basically create your initial benchmarks and then baseline. You want to keep across all the various infrastructure components. You may also want to keep track of certain application metrics. We tend to annotate when new releases are deployed, and then you might have application metrics, particularly if you're a batch-oriented workload. How long does it take to run particular batched tasks or jobs or things like that? There may be application-specific metrics that you track. And of course, the SQL instance itself, whether it's transactions per second, batches per second, and so forth. And there are lots of third-party tools out there for collecting metrics, or indeed you can build your own. Here we use SQL Sentry, but there are lots of fine tools out there, and also you can build your own relatively easily. So high availability in the virtualization world. So this is something that I get asked a lot of questions on when I give this talk. Be aware that VMware's own high availability, which is essentially if a physical host fails and you've admission control enabled, we will reboot on a new host, basically all of the VMs that crashed when that physical host failed. But as I say, it's server level only. So a SQL server crashes and the Windows OS is still responding to heartbeats from VMware. VMware will assume everything is fine. VMware does have an option that's called fault tolerance, where it runs 2 VMs in lockstep, essentially across 2 different hosts. There are a lot of caveats to running this, and typically where you would require it, the limitation of, I think, 4 virtual CPUs means it may not be an option for your VM. But essentially in this scenario where if a physical host was to fail because everything is kept in lockstep, basically there will be 0 downtime. It won't even be a reboot. And it's totally possible and often recommended to combine SQL Server's high availability options with VMware's high availability options. And so clustering, failover clustered instances is supported in VMware. At one point it wasn't, but it is supported now, but with caveats like, for example, you can have a maximum of 5 VMs in a cluster, things like that. Availability groups can be used almost without restriction. And if you're using something like availability groups, or indeed database mirroring, which still deprecated, is still around, if you're doing that, I would say to put what's called anti-affinity rules in place on the VMs, so that the VMs, and do this with clustering as well, so that the VMs always run on separate hosts. Again, it's no point in having your physical host fail and you having an availability group and having both nodes or in the availability group go down. Makes simple sense. Okay, so coming up to close to the end of the presentation. As I mentioned, a checklist from a DBA perspective. If you're looking at virtualizing an existing workload, or if you already have a workload virtualized, then maybe start thinking, do I tick all these boxes? But particularly if you're virtualizing a new workload, because it's kind of easier to set the standards up front. So one is you really want to decide if you're going to overcommit or not, and what the boundaries are going to be around overcommittal. Definitely make yourself, even if you're not directly responsible for the licensing of SQL Server, and it will depend, different shops do it different ways, but it's still important to understand the licensing implications of virtualization. At the very least, I mean, ideally you might get more, but at the very least, you should have read-only access to the virtualization tier, even if that's only the hosts that are running your SQL Server workload. You probably don't really care about anything outside of that. Have performance baselines. This is something that you should do as a matter of course anyway as a DBA, but it becomes especially important if you are virtualizing a workload or have a virtualized workload that or any kind of migration really, to have baselines in place so that you can have objective metrics to point to if there are performance issues as opposed to subjective ones. And if you have concerns about recovery time objectives or recovery point objectives that the business has put on you, or any kind of SLA really, if you have concerns about virtualizing having some impact on this, then I would make sure at the very least to document this and present it to management so that they can be aware, and as a general kind of cover yourself exercise, you should document any potential impacts to RTOs and RPOs that you previously agreed to. Okay, so in summary, virtualization can deliver a lot of benefits. You need to plan carefully and follow guidelines, and both benchmark and baseline your workload. So benchmark will be where you would take your new hardware and you would test it to see what it can do, and the baselines are basically the metrics for your typical workload, so that you can notice anomalies or deviations from that. You want to make sure that you allocate some resources or some time for any troubleshooting or optimizing queries you might need to do to alleviate CPU problems if you're going to have a reduced CPU count on your machines as you move to consolidate them in the virtualization cluster. And you need to monitor the virtualization layer in the same way that you monitor your Windows OS, or now your Linux OS as well, or storage metrics. You also need to monitor your virtualization metrics, so that it's just another layer that you might need to troubleshoot if you have problems. Okay, I think that's it for me, Tom. I will open the floor to questions if there are not questions already in the queue.
Well, there's no questions yet, Brian. We'll wait a second here and see if there are any questions that do pop up. Have you used, I saw earlier in the slide deck, you were talking about the different parts of a database like tempdb, the data files, input files. Other people, separate them out into different. Are you doing it in different LUNs, or are you just doing it in?
So I'm just specifically talking about mount points, or in this scenario, I'm going to go back to it. Yeah.
Okay.
So this is just basically what the Windows OS sees.
Okay.
If you're using,
all right.
Yeah. So assuming you're not using raw device mapping, and I recommend that you actually use virtualized disks. You're just basically creating separate virtual disks, or they could be presented as disks or mount points in Windows, and yeah, shown, so they could sit on the same data store, on the same shared storage, but I still think you should break them up into different disks.
Okay, cool.
Does that make sense?
Yeah, it does. Yeah, we were just debating this the other day about, SSD disks versus, with that being so fast, does it make a difference anymore? So,
Um, I still think it matters, maybe less so than it did before, but I still think it matters. If nothing else, you've kind of queue depth considerations. You don't, and you could overload if you're using, assuming you're using a SCSI controller, you could potentially everything will be going through the one SCSI controller, so you could potentially overload that particular path.
okay, cool.
Yeah.
Good to know.
Mm-hmm.
All right. Well, we don't have any questions coming in yet. Brian, it's always a pleasure having you on with your knowledge.
Thank you.
If you guys haven't seen him, have you ever spoken at PASS yet? Have you been at the main?
No, I have not spoken at PASS. This year I would have had an opportunity because I've been contributing to a book that's going to be presented at PASS, but no, alas, I'm not able to make it. It's one of the joys of switching jobs, I guess. But next year, yeah, hope to be there next year. If anyone does have any follow-up questions, something occurs to you afterwards, or something that you just really prefer to discuss offline, as I mentioned, I go all the way back. I should have put it at the end. Yeah, as I said there, I am available on Twitter and email, easily reachable, and usually able to respond within a day or two if you email me. So, yeah, if something occurs to you or there's something you prefer to discuss offline, please feel free to reach out.
And if you forget this, I'll definitely have it. It will be posted on YouTube later today or by the weekend. I'm not going to guarantee today, but I will guarantee I'll get it up to YouTube by the weekend, and I'll send out email to the virtualization group with the link there, so you can go up and review it or send your friends over to it if you would like to. Well, Brian, it's been a pleasure again, and thank you. Everybody have a wonderful day, and we'll see you next month.
Okay, thank you, Tom. And thanks, everybody. Thanks.
Bye-bye.